All right. Well, I'm streaming. Um, I'm gonna be making a motor mount for my plane because my previous motor mount that I was on a plane just broke when I tried to launch it, and it launched propeller fragments everywhere. So I'm just gonna make a new one. Um, I have measured the dimensions, and they are these, 45 by 34. So I have made this shape out of it. And there are some more considerations that need to be taken in order to actually, build this mount. I'm going to be fiddling with YouTube and stuff for a bit because I have no idea how any of this works. So, um, so this is the mount. Basically, what needs to happen is I'm going to show you the plane. So this is the airplane, and this is the motor that broke. This motor needs to be attached to this end. Yeah, this is a pretty like Mad Max plane with tape everywhere and everything. So this motor needs to be attached here with the mount. So it needs to go over this hole. And it needs to be secure enough that the plane doesn't, lose the motor while it's flying and just dies. So the way that happens is with this mount here. These holes go onto the motor, and these screws basically go onto the motor, and these screws go into the mount. And what I want to do now is make screws that would be able to be removed and re-screwed in, just so I can remove the mount and put another motor in and stuff like that. But also I want to add nylock, what are these called? Yeah, anyway, these things inside the mount, so it doesn't just slip away with all the vibrations of the motor. So now I'm going to get my trusty calipers. And so I already know that these holes here are 16 by 19. Let's verify. Yeah, they are 16 by 19 because it's just like a standard size for a motor to be. So I'm just going to draw them in here. We're not going to actually need them, but just in case. So to figure out the actual direction, we look at the motor, and we'll look at the motor's underside, and we see that the holes are in a square, and the cable comes out from the bottom. So we want the holes here to be correspondingly on. We don't want them to be on these lines here. We want them to be here, because we want the cable to go, to pass under or over the mount. So this should probably be like 4 millimeters. All right. So since this is 16 by 19, the distance here. Well, all right. What we do now is mirror this over this line, which creates a mirror image here. And now the good thing is that if we move this, the mirror moves as well. And then we're going to mirror these two over this line. Well, okay. So now we can move one and they all move. And now now since they are 16 by 19, we can just draw a line here and say that this is a construction line. So this is the 16 or the 19, doesn't really matter. Well, maybe it does matter actually. Let me look at the motor. Yeah. Yeah, I don't know. I'll just screw it. I'll say it doesn't matter. So 16, well, these are the 19s, and these are the 16s. Let's draw another line. Make it a construction line again, because we're not going to actually need to do anything with it. And say that this is 16. Oh, yeah, okay. The sketch could not be solved because we mirrored, so it has to be square, and it's not, so I need to undo all the mirrors. I also don't want to just draw these, like draw 4 circles, because just, I don't know, it feels a bit too loose. But maybe I will have to. The other thing I could do is just make 2 lines like this, like 45-degree lines, and then mirror these circles over those lines, which would do the right thing, but no, I don't like it. I'll just do the 4 circles. Screw it. No, I don't like this either. I'm going to do the lines. Whoops. Damn. Redraw the circle again from the beginning. Do the line. And the other line. Right, now we say that. So now we want these lines to be like perfectly in the middle here. So we'll say we'll create a point on them, on each line, and make them a construction line each, and say that we want these points that are there to be their midpoints. So we're going to choose this line and this point, or say this is going to be the midpoint, and this is going to be the midpoint as well. And we're just going to drag them over each other so they snap, and then snap them over the center. Alright, and now since these are the midpoints, if you pull one end, the other end is going to just be pulled as well. So now the other thing we need to do is say that these lines are going to be perpendicular to each other. Why did that not work? There we go. But that leaves the degree of freedom where you can just rotate them around. So what we need to do now is just say that this line and this axis will have a 45-degree angle. And they're now perfect. And we don't really need the dimensions here. Actually, we could just use these lines. Yeah, just put this circle here, and then choose this line to mirror this circle. That got mirrored, and then create another circle here. It's not too bad. And then this circle should be mirrored over this line. There we go. And I would just say that this is going to be 19 millimeters. This is going to be 16 millimeters. Come on. and we have our mount. Just 1 second. Alright, hopefully this is the correct thing. I think it looks right. So now that we know that our holes are there, we can kind of enlarge. What I want to do is, where's the mount? There we go. I want to measure how big these screws are. So over here you can see these screws. I want to measure how big they are so I can make these circles big enough that the mount can sit flush. So if I measure them, I will see that they are 7 millimeters. It's a bit too big, but let's see what happens. 7 millimeters here, 7 here, and now we have the circle, these circles, and we have these holes where the circles, where the screws are going to be. And we need one hole in the center for the, well, do we actually? Probably don't. Because of the motor's axis, we want it to be able to rotate. But since the motor sits on the metallic mount, we don't really actually need it. So I'll just leave it this way and I won't make a hole for it. But we do need to make holes for the actual screws that we're going to be using for the mount. And as you can see, they're in the shape of a cross, so we can measure the distances between them. What I do is, well, I can just eyeball the centers, but I usually do outside and inside and then average them. But in this case, the centers look like they are 33 millimeters apart, and I'm guessing also 33. Yes. Actually, it looks 32, sorry. 32, yeah, it looks like 32. Alright, so these are 32 millimeters apart, so they're square, they're not like these ones. So we can add circles here, for example. Let's make them 3.4 millimeters thick, so the screws can go in and out freely. I'm going to mirror this over this axis. Yeah, okay. And now mirror the two top circles over this axis. And 32 millimeters from this one to this one. But I need to be a straight line. I could do some math and figure out this distance here and here, like this distance and this distance. But I can't really be bothered, so I'm just going to make a straight line. Say this line should be 32 millimeters long, and just make the angle from this axis 45 degrees, and we're done. Okay. Does this look right? It kind of does, yeah. Yeah, it looks right, I think. I'm worried about the strength of this part, because these holes are too close to each other, but it should be fine, since I'm gonna have nuts this way on this side, and then the screw is going to come in this way, so it should be okay. Alright, this looks reasonable, and I also want to I want air holes. I'm gonna make some air holes. Air holes or cable holes. I'm just gonna make some arcs. Let's make some 3-point arcs here. I'm not quite sure how these are made, but let's see. Well, it looks like I got it the wrong way around. Can I even? Oh, there we go. Yeah, the center needs to be here. I think this is... let's measure. The diameter, let's make it 10. 10? How does that look? Looks a bit too big. Maybe 8. Let's do. Alright, that looks reasonable. I can pass some cables through there. The air can pass through as well. Now I want to mirror it. Nope, mirror. I never learned the shortcut keys for these, but some of them don't even have shortcut keys on OnShape. This is OnShape. Well, yeah, as you can see. What is this fillet? Oh, no, my fillet didn't work. So now I need to redo my extrude, which is easy because I just want to extrude this one thing. And this mount is kind of ready. Except the tricky part is, so the tricky part is, because this is going to be glued onto the plane and I can't, install and remove it all the time, I want the lug nuts to be kind of embedded inside it. But I'm worried that, let's see. So this is, the thickness here is 4.5 millimeters, and the lug nut height is, let me measure. So the lug nut is 4 millimeters high. Yeah, that's not going to work. So, because we're just going to have 0.5 millimeter of width for a nylock nut. So what a nylock nut is this thing. It's just a lug nut. Oh, there we go. With some nylon, a nylon ring, which prevents, it just kind of provides some friction and prevents the screw from becoming loose while flying from the vibrations. What I think I'm going to have to do, well, first of all, let me just design the nuts in the thing, and then we can figure out what to do about the width. So the nuts are 5 millimeters. Are they? No, they aren't. They are 5.5 millimeters wide, which means, well, I want them to be press fit, which means I want them to be able to be pushed into the plastic and not come out. So I want them to be very, very snug, which means I'm just going to design with 0.1 millimeter of slack, probably. Let me measure an actual one. I don't think I'm going to use nylock nuts. I think I'm going to use normal nuts and just periodically make sure they're screwed in. Normal nuts are 5.2 millimeters wide, so I'm just going to go with 5.3 millimeters. They're 5.2 millimeters wide and 2.2 millimeters high. So okay, let's do 5.2. They are hexagons, aren't they? They are hexagons. So let's just make a hexagon. I usually do, well, inscribed polygon because that's what I measured. Let's do an inscribed polygon here. 6 sides, six sides, there we go. And the diameter of this should be, what do we say, 5.2 we said? Let's measure again, because we forgot. No, 5.3. So I want to make it 5.4. So the diameter should be, the radius should be 5.4 divided by 2. I don't want to do mental math. So, since we have 2.7, I don't like this being rotated the way it is, so I'm just going to say that one of the edges should be horizontal, which locks it. So you see it was blue and now it became black, which means it has no degrees of freedom anymore, so it can't rotate or anything. So now that we did this, I can mirror it to all the other positions. Yeah, well, I could select these things. So one of these ways of selecting selects the whole thing. Oh yeah, no. If you select from left to right, it will select everything you're touching. And if you select from right to left, you see this is blue, the other one's yellow. If you select from right to left, it will select everything you have completely enclosed. So maybe it's the other way around, but if you do this, it will just select this line because this is the only thing that was completely enclosed. But if you do this, it will select this line and the other ones as well in the circle because you were touching them. Because any part of them was inside the selection square. So I'm actually going to select these by hand now because I don't want to touch the other circle. So I just do this, 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 and this. And we see that, okay, we got it. All right. So let's do another mirror. I want to do, again, sorry, this. We got that, and this we can just, well, we could select, but I don't want 2 circles, I don't want the inside circle twice. So I'm just going to click everything. Again. There we go. Okay, now this is good. So what we need to do now is extrude the holes. Just need to extrude these holes in here. 1, 2, 3, 4. And because these inside circles are construction circles, you can see they're dashed and dotted and not solid. They don't get selected when you select with a mouse. So now we can just easily extrude this, and we'll say that okay, come on. Anyway, yeah, this is not working for some reason, but anyway, wait a minute. I'll just reselect them. Okay, first of all, let's figure out the dimension before we do anything else. This is 4.5 millimeters, and the nut is, we said 2.2, 2.2, okay. 2.2 millimeters minus 4.5 means 2.3, so we want to extrude these holes in here. Come on. We want them extruded by 2.3 millimeters. Are they extruded the right way? They are extruded the right way. Okay. So now what this means is that we can put the lug nuts in here and turn this around. This is going to be mounted on the back side. We can just stick the motor here and then screw in from this side. The screw will go into the back onto the lug nut and just catch. The only problem now is that there's nothing holding these nuts in, I guess. There are a few options. What we could do is make this thicker and leave a hole here. So let's say this gets printed this way. So while the printer's printing, these holes, we could make these holes covered. So basically, duplicate this extrude. No, we can't duplicate. Anyway, just to demonstrate, let's say this thing, we could extrude up to here, up to this face, but have a offset distance of, say, 4. This is not correct. The distance is not corrected, but just to show. No, this is not correct either. Anyway, 4 millimeters. The other way, which would basically make an extrude. It would make a hole for the lug nut in here, but then close it at the top. And the way the printer prints means that it's going to lay these layers down and then come up to this layer here. And before it starts closing the hole, you can tell the printer to stop. You put the lug nuts in, and then you tell it to resume, and then we'll just go and fill the holes up, and then you have the lug nuts securely enclosed in there. But that sounds like too much work, and I would much rather just, glue them in. Just stick them in, press fit them, and put some CA glue and just glue them in there. Yeah, I think that's what I'm going to do. The only problem now is since these holes aren't symmetrical and I can't mount the motor the way I want it, I don't want to make a mistake and actually find that the way I've designed this, the motor cable actually comes out this way instead of this way here where I want it. So I'm just going to get the plane and double check for sure that it is that way. So we have the motor here. The two long ones are, as I'm looking at it with a cable down, the 19 millimeter holes are top right and bottom left, which means that since they're top right and bottom left this way, they will go onto the mount. If I want, well, let's say that I want the cable to go up, which is what I actually want. Shouldn't really change anything because up and down is the same, but alright, so top right and bottom left, they go in this way, which becomes top left and bottom right. And my top left and bottom right, as I'm looking at them, are they're correct. So this should be okay. Let me rotate the plane so I can actually face the screen that way, just to make completely sure that I haven't made a mistake. Yeah, no, it's correct. Okay. And since this is correct, I guess we can start printing. Is there anything else we need? Do we need the motor shaft hole? I think we might need a motor shaft hole. I think there might be a reason for the hole that I don't know, and I don't want to risk it. Let's just make a hole for it. It's not going to be hard anyway. Just make a hole here. 7 millimeters sounds okay. Alright, this sounds okay. It looks okay, I mean. So, just to triple check that I haven't made a silly mistake. Is there anything else that I want? I think no. The lug nut hole is a bit too close to the 19mm one, but it shouldn't really affect anything. I can just put the lug nut in and it's fine. These holes should be big enough that the screws can go in. As regards structural integrity, basically all I need is for these points, these four lug nuts basically to be solid, and it looks like they are. Yeah, because this, well, yeah, they're going to be glued from the back here. Well, actually, they're going to be glued here. This is going to be glued. This side is going to be glued, and this side is going to be glued. So this seems okay. Yeah, I think this looks reasonable. All right, let's export it. All right, exported. Now we can go to Prusa Slicer and slice this thing. There we go. All right. I think I will print one with draft quality just so it's printed quickly, and I will be able to test whether, you know, everything fits and it goes correctly onto the mount and the lug nuts work and everything. This looks okay. This looks like it's going to print quickly. Yep, this looks reasonable. So I'm going to print it in PETG because just I don't trust PLA for this kind of thing, and PETG, well, PETG has been very good for durability and just strength, but only when I use glassy, like transparent PETG. When I used white PETG, it was a bit more brittle. It was kind of like PLA, and I didn't really like that. It was easy to print and it looked nice, just didn't really. I used PETG mostly for the strength, and I didn't really like the fact that it wasn't really very strong. Yep, I think I'm going to just go print this. I'm going to stop the stream, print it, and see what happens with the test print. And then if it's, well, I don't really anticipate any problems. Maybe I need to change a dimension or something. But after that, I'm just going to, yeah, mount it. And I think that's going to be it. I think it looks really, really nice. I don't really see myself needing anything else. Yep, I think this is fine. Well, anyway, that's it. We designed our part, and it looks ready to print. So I'm just going to stop the stream here. Thanks for watching. Bye.